Hey guys, welcome back. I have a 2000 Toyota 4Runner that has an instrument cluster issue and this code in the ECM, P1780 transmission park neutral position switch fault. Now the prindle up on the dash, the park neutral indicators, they kind of behave strange as well. So I'm going to go over the circuitry and what the problem I was having. So here's where the bulbs would normally go in. We have park, reverse, neutral, drive, second, and low. Now I have all the bulbs removed at this time, but I did have them in place while I was doing some testing in the vehicle. Sometimes you'd hit a bump in the road and then everything would light up bright like normal, but most of the time you would have a dim reverse light lit up no matter what gear you were in. So one of the first tests I did is I hooked up my meter to ground on the vehicle, chassis ground, and then I just went to the ground side of the bulbs. Now I could flex the circuit board and I could get anywhere from 0 volts up to 5 volts. So I wasn't getting a consistent solid ground. And then when I looked at the lap scope, I kind of had an up and down pattern here as I flexed the board. And I was watching this trying to figure out exactly where on the board was causing the issue. All of these bulbs are tied together with the same ground except for the drive indicator. So this wire kind of comes across here. We can see that the board is actually labeled ground, and then it goes underneath that circuit board where we can't see it. Now the primary board for this instrument panel is a flexible circuit board. It's kind of like a ribbon cable, which makes it hard to repair. Now there is a solder joint right here, and we can see a dotted line where it goes over to the ground on another bulb. So that, could become a common test point for us. So after that, I still use the same chassis ground, and you can see a couple of pin pricks in the circuit board where I moved my meter lead around the other side of that solder joint to that side of the board. And when I'm located over here, my meter does not fluctuate. My graph stayed a steady 0 volts. I didn't have any fluctuation. So I'm suspecting a bad solder joint at this location, but being that it's a flexible circuit board, we have to use some caution. If we get it too hot and melt the plastic, then we're going to have some additional issues. It's hard to repair the flexible circuit boards, or at least I'm not very good at it without causing more damage. So I normally look for another way of repairing these. Now, if we look at our drive indicator, it has its own separate ground and power that's not tied into all the other ones. So that's why it doesn't respond the same way. Whenever you're in drive, we don't normally see the reverse light lighting up, or if it does, it's very dim. But since all of those traces go underneath that big circuit board, we can't really, find out what's going on until we remove the circuit board from the instrument panel. It looks like everything should just disconnect from that board, and we can lift that board off, and then we can see the full flexible circuit board. Now, once I had that circuit board out of the way, I just kind of looked around, and I found that if I flex the circuit board, the flexible portion, I could actually see a crack in the solder joint. We'll have to desolder this and find out if it's actually the solder joint that cracked or if the board cracked. And I also just, solder wicked some of the solder away from that point. And let me show you a different view, but we can see actually a crack in the flexible circuit board, and it's not necessarily a bad solder joint. Let's go ahead and trace this circuit on the circuit board and find out where it goes. So you can see my Sharpie marks where I did this in the shop. It kind of forks out here, so we need to find out where each one of these goes, and it looks like this lower fork just goes to a couple more bulbs, just a ground circuit for those bulb indicators. And then 2 of these come up to 2 contacts on this flexible ribbon cable. Now it splits out to 2 contacts, and that's probably because an individual one can't carry enough current, or they're just kind of safeguarding it to prevent it from getting hot. It's better to have some backup here. So there's 2 contacts coming off of this flexible ribbon cable. Now this flexible ribbon cable was attached to the circuit board that was on this unit. Before we go back to that other circuit board, let's look at our drive indicator now that we have that part of the circuit board out of the way. Our ground goes to this solder joint, and we can see a resistor marking on the board. So there's a resistor underneath this flexible circuit, and it ties us into the same ground as our other bulbs. So that's just one path for that bulb, and the other one comes up here, and there's a diode indicator. So on the bottom of the circuit board, there's a diode which is going to allow current to flow in this direction to our illumination circuit. So what this is doing is when our illumination is turned on and we have 12 volts on this wire, we're not going to be able to get a ground out of that. But the diode's going to prevent the 12 volts from backfeeding into our drive indicator. And what this will do on most vehicles that have this type of setup is the drive indicator will be dimmer than normal whenever you have the headlights on, because there's only one path for that drive indicator to ground, and it's through a resistor. So it's going to be dimmer, so we're not being blinded by our drive light at night. Now, if we look at this flexible ribbon cable where it connects to the other board, we have our two wires here that go down to our ground circuit. And then we also have a couple of them that aren't being used, and then a couple other ones that are bridged together. Those may be a power source. I'm just counting from the end here, just so we can, figure out what pins we're using once we look at the other side of the board. Now here's the other connector. Now I see that this connector is labeled the opposite way that I labeled it, but we're just going to count 1, 2, 3, 4, 5, 6 from this end, because that's where my marks line up. And we can see, which pins are used. Now 3 and 4 is not being used on that flexible ribbon. 1 and 2 is probably a power or another ground. And 5 and 6 are the ones that we're concerned about. So we need to find out where these pins go. If we look at the back side of the board, there's actually 2 solder pads that aren't being used over on the right hand side. There's nothing, those are beyond the point of that connector. So we don't have to worry about those. We don't have to count those. We're going to start counting from here. 1, 2, 3, 4, 5, 6. Now they do stagger them here, even though they're perfectly in a row on the top side. They just need to space them apart for soldering on the bottom side here. Now you can see my black Sharpie marks where I marked 5 and 6. 3 and 4 aren't being used, and 1 and 2 are being used for something else. Now I find it very helpful to use a flashlight to shine through the circuit board so we can see the circuit traces. So we're going to count these back out. 1, 2, 3, 4, 5, 6. And looking at this, I don't see any traces connected to any of these pins. 1, 2, 3, 4, or 5 and 6. Now, my black marks make it a little more difficult to see, but we don't see any actually hard traces connected to those. So more than likely they're on the other side of the board. So let's flip this board over, shine through with a light, and see if we can find these traces. Now here we can kind of see the third trace, or the third pin does have a trace connected to it. And these are going to be the odd pins here. So we can see that number 5 does have a trace connected to it. Let's look from the other side and see if number 6 is tied to number 5. More than likely it is, but sometimes they will go to different places. So on this side we have 2, 4, and 6, and we can kind of see number 6 going underneath that connector. So it's heading straight over to the number 5 pin. And at this point I'm really just looking for a place that I can easily add a wire to put an overlay on this circuit board. Since it's going to be difficult to repair the trace that's damaged, I would like to tie in another wire somewhere. We can go to that solder point where the board is broken and basically bypass the section that is broken. We'll just keep following this trace across the board and see where we end up, see if it's a easy place for us to tie in. Now we could have gone back to pin 5 or 6 on that connector and soldered a wire in, but they're kind of close together. It may not be the easiest place. So I'm just looking to see if there's an easier place for us to tie onto. Now we see that this trace just ends, it disappears. It doesn't go any further. Well, what this is from is there's a little hole through the board, and they call those a via. And it's basically a pass-through for electricity. They're passing that trace from one side of the board to the other side of the board. So once again, we'll have to flip this board over and follow the trace from the other side. Now this via is located right next to this white connector, and we can see a large trace at the corner of this white connector where one of the pins is mounted. So we're just going to use this as a reference for when we flip this over to find out where that via goes. And we can see the header pins here soldered to the board, and that one there is right next to this via. And we can see the via here. So now we can follow this trace and find out where it goes. Now it seems like a lot of these traces, they go back and forth on the board. They go through multiple connectors. So we're just looking for an easy place to attach to. And since this electrical connector is a little bit bigger, these pins are spaced out a little bit further than they were on that other pin. So I can see this as a very easy place for us to tie into, and we're just going to run a wire over to the flexible circuit board, and we're going to tie in at that solder joint where the board's cracked. So that's what I did. I pre-tinned this wire, bent it into a little horseshoe so I could go around that pin, soldered it on, and this is the same pin that goes to our ground. So I soldered this blue wire on there. Now you have to be careful because we still are fairly close to the other pins. You don't want any solder bridging between these pins. We don't want to short something else out. So just make sure that your solder is not connected from this pin to the other pins. And then we'll reassemble this. I left plenty of extra wire. This is just a wire I cut out of an old harness so that I had enough slack to make it to that other solder connection once we reassemble it. So I remounted that board, ran the wire out of the board over to my solder joint where I wanted to attach it. I pre-tinned the wire, bent it into a horseshoe, and soldered it to that point. Now we still have the other trace, and it may carry some current. Me reflowing that solder may have bonded it for a while, but it wouldn't have lasted. So this extra wire will definitely share the load. And once that board breaks again, it doesn't really matter because we have this wire to carry the load. Now that it's all back together, we're just going to test it, make sure that all the indicators light up brightly, and they do. Flip the headlights on, make sure they don't behave strangely. Everything seems to be working properly. Now, did you see that drive light was dimmer? That's supposed to do that. It's going to toggle dim whenever we have the headlights on. So at this point, everything's working properly. Just got to clear codes and give it back to the customer. If you enjoyed this video, give it a thumbs up. If you want to see more videos like this, subscribe and click the bell. Thanks for watching, and I'll see you next time.